Lesson 1.2, we're looking at transformation functions. This is a huge Algebra 2 topic. This little chart up here, I don't know how you won't have it memorized by the end of the year because we're going to use it so much. Okay, we are going to use this chart a ton. Now, what I will tell you, first of all, I'll explain it, make sense of it as we go. Okay, but I'm also going to tell you that I'm going to provide this chart on quizzes and tests right now. Okay, so I have I don't have them copied yet this year, but a formula page or something, and that will have this on there. Okay, so work to really know and understand this chart. It is important, I promise. Okay, it's one of those things, you know, there's always certain topics that keep coming back at you. Guess what? This is one. This will keep coming back over and over and over. And so I addressed this a little bit in some of the classes on Friday, not by chart, but just because we graphed a few things and I talked about moving things left or right and up and down. Well, this is where this chart comes into play, okay? F of x standing for the function. So like today as we talk about the function, our function is going to be the absolute value function. When we get to the quadratic part of this lesson, our function will be x squared. But for today, when we talk about the function, it's just going to be square root of x. If you take and say plus c, keep in mind c is a number, okay? If you take and you just add a number at the end, then that's going to tell us to translate the function up so many units, okay? And that is just if that number added is at the end of the equation, outside whatever else is going on, it will tell you to go up or down. Well, excuse me, the plus will tell you to go up. So what's the minus c going to tell us to do?
Go down.
Minus c is going to tell us to go down, okay? And that is if the number is at the end, outside of whatever's going on. So in this case, we're going to talk about being outside of the absolute value. Later this week, we'll talk about being outside the x squared. Then the next two, notice the difference is plus c and minus c are inside the parentheses. So this is when you have a number added or subtracted and it's with the x. In today's reference, we'll talk about being inside the absolute value. Later this week, we'll talk about it being inside the x squared, so to speak. So notice now, are you reading? What does plus c inside the parentheses tell us to do? Left. Okay, you'll often hear me say opposite the sign. When we go to move left or right, it's opposite the sign. So plus c inside the absolute value, the squared, the parentheses, whatever, tells you left or right. Plus tells you to go left. So what's minus c going to tell us to do? Go right c. Okay? We're going to use those a ton. You'll know those. Okay? Now, negatives. Just a negative multiplied by something is going to be reflection. A negative in front of the function. So a negative in front of the x squared, in front of the absolute value, in front of whatever is going to reflect across the x-axis. If the negative is specifically on the x, so it doesn't really happen in absolute value as much. I guess it does a little bit, but more like in the squared or something. If the negative is on the x, it's going to reflect across the y-axis. Then we have multiplying by numbers. Okay, for whatever reason, they change from using c to a here. But if you have something that multiplies by a number, it's going to either stretch or compress. Now, we talk about vertically stretching, vertical being up and down, right? So vertical stretch means that it's going to take the function and it's going to stretch it up. Okay, in the process, it kind of makes it appear taller and skinnier. This is when you're multiplying by a value, and notice it's a vertical stretch if that value is a number bigger than 1. So if you're multiplying by those whole numbers, 2, 3, 4, 5, or fractions bigger than 1. If you multiply by a number, notice the difference is this time, the number is less than 1. Officially, it's listed as a number between 0 and 1, indicating basically that it's positive. Okay, we're not talking negatives right here. But basically a number between 0 and 1. So now you're talking about your little fractions and decimals. If we multiply by a number that is between 0 and 1, it's a vertical compression. We'll think opposites. If stretch stretches it up, compression is going to squish it down, okay, compress it down. Now, think about what's happening to the function as you squish it down. Instead of, it's going to go from being taller and skinnier to shorter and wider is the appearances. Okay? Now, and I will say, those are the ones we use the most. I'm going to throw these in. We don't use them that often this early on. Okay, so don't be surprised if you don't see them at all. Not saying you won't, but these options, notice the a value is inside with the x, and it's dividing. So if it's x divided by a value, the value is greater than 1, it's going to be a stretch, but this time it's a horizontal stretch. What's horizontal stretch going to do? Going to pull it wider. A horizontal stretch and a vertical compression are related. Okay? They are the same thing, and we can talk about factors when we get to that point. Horizontal compression, this is again if you're dividing by a value, that is if the number is a number between 0 and 1, you get the compression. Now, think about what's a horizontal compression. If you take something horizontally and you compress it, it's going to end up going taller, right? Longer, taller. Okay, I would have said taller. It's going to end up going taller. Well, guess what? Horizontal compression matches up with vertical stretch. Okay? In all of these, the parent function, I'm going to use the word parent function, is f of x. So as I said, today in everything we do, that f of x is going to be absolute value. Later on this week, it'll be x squared. Maybe another chapter will be x cubed. We'll have different ones. But your parent function, anytime it asks about the parent function, think of it just that original function before numbers get added, subtracted, multiplied, divided. Okay? So that's a hugely important chart. I'm telling you up front, I'm going to have that on a piece of paper that you're going to be allowed to use on quizzes and tests. Okay? So, and I will, when I get it copied, I'll hand it out to you. I just haven't gotten it out and copied yet this year. Okay. With that in mind, our parent function today is the absolute value parent function. I need you guys to know how to graph the basics about absolute value function. Okay? Last week I said use Desmos, right? I said just use Desmos, go from there. Today I'm going to say no, don't use Desmos. Today I want you to use your brains. Okay? So today I'm going to teach you, okay, this is how we graph the absolute value parent function. And then we'll learn how to use this chart with it. So today when you're doing graphing homework, I don't want you relying on Desmos. Okay? Make sense? I want you using your brain, learning how to graph these. Because here's the deal. You'll have to graph something like these on upcoming quizzes and tests, and you won't be allowed Desmos on a quiz or a test. Okay? So, just giving you a heads up there. I don't know. You guys know what an absolute value function looks like? We talked about it a little bit last week, but I don't know if you really caught on to what it looks like. Do we know the shape of it or anything? The V? We had that in homework, didn't we? And I mentioned it, the absolute value, or in the notes, the absolute value is going to be the V. Okay? I have an XY chart here to get our specifics. What are good values for an XY chart, if you're not told anything? What else? Notice I have 5 blanks here.
3, 4, and 5.
I'll give you a hint.
Negative.
Negative 1, negative 2.
Now, and here's what I'm going to say. Do you always have to do negatives to get the right shape? Not necessarily. But what I'm going to tell you on this one is if we don't use negatives, we're not getting the right shape. Okay? So, okay, that's not the way I really wanted that graph that filled in. Sorry. Negative 2, negative 1, 0, 1, 2. My apologies. Not that it really matters in all technicality, right? So negative 2. If we take negative 2 and we put it in right here, what does, so it's going to be y equals absolute value of negative 2. What is that equal to? Ruby? 2, yes. Absolute value takes the number and makes it positive. It's distance from 0. Okay, so what happens when we put negative 1 in here?
1.
Absolute value of negative 1 is positive 1. What about when we put 0 in here? Absolute value of 0 is 0. Absolute value of 1?
No, just 1.
Oh, just 1. If a number is negative, it makes it positive. If it's already positive, it stays positive, right? Okay. Absolute value of 2?
2.
2. Okay. Let's graph this. Negative 2, 2 tells me we're going to go left 2, up 2?
Down two. No, left two, up. Negative two, left. It's not.
So it's not negative 2, negative 2.
It's negative two, positive. Oh, yeah, Paul's right. I'm wrong.
Negative 1, positive 1. Left 1, up 1. 0, 0. 1, 1. Right 1, up 1. 2, 2. Right 2, up 2. Is that the V shape we expected?
Mhm.
Yeah. Okay. So with this V, obviously, I can't draw it perfect, but it's going to extend indefinitely. Arrows would be included. Okay. When you look at it, you can kind of, we'll talk at some point when we get to it. You can kind of think of it as slope on either side because both sides are going up 1 over 1, aren't they? And if you think about that being up 1 over 1, notice out in front of the X, there's just an invisible 1. So you can kind of think about that being slope. A little bit of vocabulary, a little bit of preparation for homework, okay? Vertex. You have to be able to state your vertex. What's my vertex?
0, 0.
0, 0, right? Vertex being this point where the two sides meet. And so it is the ordered pair 0, 0. What about axis of symmetry? You remember? I don't know if you guys remember that vocabulary or not. It's been a hot minute, right? What do you remember, Logan? Okay. So y-axis, because what's an axis of symmetry do? It splits it in half, right? It's that line that I could take that V and I can't even demonstrate that, but you're going to fold it in half, right? And it's going to land on top of each other. Now, Savas isn't going to want you to say y-axis. I'm not disagreeing with y-axis. I do agree it's the y-axis in this case. What is the equation for that line? It's a vertical line, goes through the origin. You remember, Toph?
Is it y equals 0?
Half right.
Equals 0, 0.
No.
0.
If you tell me y equals 0, and I know it's hard to keep these straight, y equals 0 is the x-axis.
0, x.
So then process of elimination, it has to be x equals 0. Okay, a couple of hints I can give you. First of all, axis of symmetry, vertical lines are always x equals, okay? And I like to think because it's a line that cuts through the x-axis, so this is a vertical line that cuts through the x-axis at 0, so x equals 0. And I will tell you a connection is that your axis of symmetry is always the first number in the vertex. So if you know your vertex, for axis of symmetry, you just have to say x equals, and it's that first number in the vertex. I know in this case they're both 0, so you're pretty guaranteed, but it's always x equals the first number in the vertex. Okay? Questions there? This information is the important basics to get you through the rest of the lesson. Okay, shall we try some examples?
Yep.
Okay. Graph each function, identify the transformations, vertex, and axis of symmetry. And this is all in an effort to have you ready for what homework is asked you to do. Okay? Homework definitely, I will tell you, homework definitely lines up with the notes a little bit better this time. Okay? I can assure you of that. So if you're hesitant about going into homework again this week, it'll be better, I promise. I made sure of it. Okay? So, y equals absolute value of x plus 4 plus 2. Any thoughts about this one? Patrick?
Would you start at y2 or x2 for your vertex?
Start at what?
2.
2? Depends what 2 you're talking about. There's a 2 involved.
Negative 2. Would you start at negative 2 because it's opposite of the sun?
No. Let's think in terms of, before we jump to the vertex, first of all, we see absolute value, yes? What's that mean this graph is going to look like? Brain automatically has to say, okay, I know it's going to be a V. Now, my normal V starts at
0,
0, 0. I want to know, where's this v going to move? Let's think about it in terms of that. It's going to move to what?
To the right.
Okay, so I'm hearing disagreement. Go back up here. Where is the +2?
On the outside.
On the outside at the end, right? It's not in the absolute value with the x, it's on the outside at the end. What's a plus? I went the wrong way. What's a +2 going to tell you to do? Go up. See how to use the chart there? Okay, so that's half of what we need to know, is that this 2 is going to tell me to go up 2. What about the 4 now? Use that chart.
Oh, that is
The left.
still
The left.
Are
right.
we seeing that?
Yeah.
It's a +4 inside the parentheses, yes? Okay. Inside the absolute value. So that's going to tell me to go left 4.
Oh, that makes more sense.
So the next day of notes look very much the same at the beginning, don't they,
They
Paul?
are very much the same.
Because when we do lesson 1-2 quadratics, I start with the exact same chart.
All right.
Okay? However, we're doing absolute value, not quadratics. Okay? Make sure you're on the right page of notes. I'm like, why is he looking so confused?
Right.
And then it dawned on me why you were looking so confused. Are you guys in agreement with the left 4 up 2 now?
Yes.
You can see based on using that chart. And the last one, that +4 is in the absolute value. So that's like in parentheses, left or right, opposite the sign. So that's a left 4. Yes.
Will we have to memorize the chart, or will it be provided?
Usually it's provided. I don't know. First semester it's at least provided. I can't guarantee. Second semester we don't use as much. But in all honesty, guys, you use that chart enough, you're gonna know it.
Yeah.
You'll know it. But yeah, for the most part, it's provided. Okay, so let's go ahead and graph this. Now, my personal way of graphing this, notice I didn't put an XY chart here, did I? Because I don't want to use an XY chart. Normal absolute value V starts where? With the vertex at 0, 0. But what do we know about this problem?
We gotta go up to
Up 2 and
left 4.
left 4. So I'm going to take my vertex that's normally at 0, 0, and I'm going to count 1, 2, 3, 4, 1, 2. There's my new vertex. Okay? From there, absolute value. Your brain has to process that absolute value is going to make a V. Notice there's no number out in front of the absolute value, is there? So you're going to think slope of 1. Up 1 over 1. So that means I'm going to go up 1 over 1. Up 1 over 1. How do we get the other half of the V? Up 1 over 1 on the other direction. I tend to do 5 dots. You guys can guess, Savis, you don't have to do that many dots. I honestly don't remember. You know what? I think more of the graphing was more multiple choice than anything in this homework, because I don't remember graphing any when I checked the homework. So, okay. Now I will say, when it gets to my quizzes and tests, you're going to have to graph them by hand, though, right? Now, okay, back to the directions. What did we have to do? One thing it said to do was to identify the transformations. Well, what did we do? We moved the graph left 4 up 2. Now, vocabulary word. I said moved. What's our official algebraic word here?
Translated.
Translated, which is up at the top of your paper. In all honesty, if you write moved, shifted, something along those lines, I'm fine. Savis is probably going to say translated. So for my transformations, I'm going to say translated left 4 and up 2 units. Because you're in Savas for homework, Savas will have you picking that from a multiple choice type situation. Okay?
Could we write it in parentheses, like 4, comma, or -4, comma 2?
No, I'm going to expect words. Because what's -4? Is that left 4 or is that down 4?
Right.
Okay, so I'm going to expect, if they want you to identify the transformations, I'm going to want words. Okay? Okay, the vertex. You have to be able to type in the vertex. Thoughts on what my vertex is going to be? Patrick?
-4, 2.
Okay. We went left 4, up 2. Here's where I want the parentheses for -4, 2. Okay. And then we're also asked for the axis of symmetry.
-4.
No, we have to do y for x. X equals,
No, it'd be, yeah,
x equals 2, right?
no, x equals -4.
-4, 2.
So I agree with the -4 in that the axis of symmetry, think visually, right? It's going to be what goes through here. And what x value is that happening at? That's -4 there, isn't it? Okay, that's a -4 value. So it is -4. Because it's a vertical line, it is x equals -4. If you just type -4, guess what?
Wrong.
They're going to count it wrong. Now, in all honesty, I could see Savas already putting the x equals in for you. Beware, 50-50 shot. If you just write -4 for me on a quiz or a test, I'm going to count partial credit. It's not just the number -4, it is the line x equals -4. Okay? And notice, I don't have a good connection spot here, but which number did we do here? The first one. And notice it's in the x value spot, right? So it's x equals -4. Questions? Okay. Let's try the next example then. Y equals absolute value of x minus 3 minus 5. What do you need to know to graph this? Ruby?
Right 3.
Okay, you guys agree with her right 3? This is inside the absolute value, which is similar to being inside parentheses. If you go back to your chart when it was minus c in the parentheses, that's equivalent to moving right c. And again, I summarize it by just saying in the absolute value, in the parentheses with x, left or right, opposite the sign. So minus 3 would be right 3. And, Jayden?
Down 5.
Okay, a minus 5 at the end is going to be a down 5, right? Okay, again, if it's at the end, outside parentheses, absolute value, it's up or down, and this time it's direction of the sign. The sign is a minus, so we're going down 5. Okay, can you graph it?
Yep.
Take that vertex that's normally at 0, 0, and move it. Right 3, down 5. What do I do from there?
Use the slope of
And dots.
Okay. Slope of 1, up 1 over 1, and then just reverse it to get the left side, right? These absolute value v's are always symmetric. One thing I will say, when you do this on paper and pencil, I never want you to just have just the vertex as your only dot. I should always have at least one other set of dots that you're drawing through. Because otherwise, if I just do the vertex and I just go, well, that was horrible, but if I just go horrible, did I necessarily make it through? I actually kind of did, but if you draw it and it doesn't go through at all, then I can't give you the credit, okay? I need it to show me, the size of it, the shape of it. Okay, what else did we need? Identify the transformations. Put it in words. What were my transformations here that we just did? Lucy?
inside the right 3 and 1.
Sounds good to me. Translated. right 3 and down 5 units. Good wording. Thoughts on the vertex now? What do we got there? Adriana?
3 negative 5.
Okay. We went right 3, down 5, so natural to say 3 negative 5. And axis of symmetry is our last one here. Patrick,
X equals 3.
you guys like that this time?
Mhm.
He picked the x value. He said x equals 3. He didn't just say 3. Am I getting you guys trained on the axis of symmetry?
Yep.
As crazy it is, that's one of the hardest things, just because we don't want to give that form. You guys want to fight me there. Okay. On the back side, we get to start talking about stretches and compressions, okay? Hopefully you've kind of got this vertical, horizontal translations mastered. This is the easiest stuff, right? The left, right, up, down, this is the easier stuff. Stretches and compressions we have to think a little bit more about, but we'll get there, okay? Now, let's see, directions here, graph each function, identify the transformation. What do you notice here?
It has something in front of the absolute value.
Okay, we have something in front of the absolute value, don't we? It's not added or subtracted, is it? So go back to your chart. This is why I give you the chart, right? And this is what I'm always going to say at the beginning right now is if you're not sure, okay, go back to your chart. Use that chart to help you think about what this might be.
Would it be a vertex stretch?
I'm assuming you mean vertical.
Vertical on that side.
Okay, I don't know. What do you guys think? Vertical stretch is what Paul was suggesting, maybe?
Because it's more than one.
I don't know.
Maybe over there.
You found your own issue as you started to talk about out loud. You're halfway there, I will say that.
Unless
Go ahead, Ruby.
Horizontal compression. Is it a fraction?
It is a fraction, but it's not with the x.
yeah, X is
Does that make sense?
Yeah.
If we're talking fraction where it's x divided by something, then we could talk horizontal. Okay? Logan?
yeah, vertical compression.
Okay. Vertical because the 2/5 is outside. It's something multiplying. So this 2/5, I have to back up 2 pages to get there, but it's like the A out front, yes? Now, stretch versus compression, 2/5. 2/5 is a fraction value that is less than 1. So our transformation is going to be a vertical compression by a factor of 2/5. I'm going to go ahead and write that here, and then we're going to talk about how to graph this. Okay. Vertical compression by a factor of 2/5. Okay. Now, we have to graph this thing. Thoughts on where my vertex is? Do we have any reason to move it?
No.
No, we didn't move it left or right. We didn't move it up or down because we didn't have any plus or minus numbers, did we? So my vertex is going to be at 0, 0. What's changing? Instead of going up 1 over 1, we have to think differently here. Okay? And I'm not sure if this is how I should teach it or not, but this is the easiest I've come across over the years, is that if you think about this as a slope, what does a slope of 2/5 tell you? Yeah, rise over run. So if a slope of 2/5 tells me that, now here's what I'm going to tell you to do. Can I do up 2 over 5 and that's it?
No, you can do that.
We also have to reverse it, don't we? And so what I usually suggest to students is that we're going to do a slope of 2/5 on the right. Then, after you do a slope of 2/5 on the right, reflect it on the left. And I think I even say right branch, so to speak, if you will, right side, I don't know, right branch, and then reflect on left. Now, this is just me trying to give you helpful directions. Do you have to write that down? No. Our transformation is a vertical compression by a factor of 2/5. How do we actually do this? We're going to start at 0, 0. Slope of 2/5 says we're going to rise 2, run 5. Yes? So from this point, rise 2, up 2, run 5. Can you do that again? You can, just barely. My graphs are usually 10 by 10, so. Now, if I stop here, what am I going to draw?
Oh,
Straight
just-
A straight line. So this is where you have to know its absolute value, yes? And so now I'm going to go back to the vertex, and I'm going to go up 2, but left 5. Up 2, left 5. And then we can connect our dots. Ooh, or we can miss the dots, that too.
Yeah, are you real strict on our or our lines being totally straight?
No. Here's where I'm going to take effort into account. Notice my lines aren't always real straight. But what's in the correct spot? My dots are in the correct spot, yes? Can you tell what's supposed to be going on if my lines get kind of wonky?
Yeah.
You can tell. Now, if you draw some random V elsewhere and don't really follow your dots, or you don't put dots, then I have a problem. But as long as I can tell there was effort in, there and the dots are there, I'm going to go for it.
We're not gonna have to bust out the ruler.
However, I will say, because I know some people are more picky about their own stuff, I do have over here, if you ever need to borrow them, I keep a set of the Rose Holman rulers. So, if you ever want a ruler in class, feel free to borrow one. Okay, where are we at? 8:41. We could talk about this one a little bit, but I have a feeling I'm going to have to graph it tomorrow. Just because I don't want to totally get us caught in there. Because, what's going on with this one?
It only has one number.
Okay, has one number.
The absolute value is after the. Well, never mind.
It's a -2,
It's a -2.
and there's no absolute values.
Yeah. Logan?
You have to reflect the function across the x-axis.
Are we going to have a reflection here? Okay. Right here, and we'll talk tomorrow, because I don't want to get caught in the middle of this and leave you guys in confusion. We'll talk tomorrow that negative is going to mean a reflection. What's that 2 going to mean? If we ignore the negative, I can't do that. If we ignore the negative, what's the 2 going to mean? Not a vertical compression,
Horizontal compression.
no,
Vertical stretch.
vertical stretch. So we'll talk about this one tomorrow. This one has 2
That's the same
pieces.
thing.
Okay, now, time out. If you go into SAVAS, with the exception of one, okay, if you go into SAVAS, you will see lesson 1.2 absolute value functions in there. Can you start working on it? Yes. Is it due tomorrow? No, because I didn't finish my notes, which I knew I wasn't going to finish the notes. So when you go into SAVAS, you will see that this assignment is due on Wednesday. Okay? Tomorrow, we will finish the notes, and if I had to guess, you'll have a little bit of work time in class. Okay?
Perfect.